Hello students, this is a question from I.E.IRODOV. It is a question number 3.143. Question says a parallel plate capacitor was lowered into water in a horizontal position with water filling up the gap between the plates D equal to 1 millimeter wide. Then a constant voltage V equal to 500 volt was applied to the capacitor. Find the water pressure increment in the gap. So as given in the question, let me draw the parallel plate capacitor. I have already drawn here. So this is the parallel plate capacitor. This is a parallel plate capacitor. These are two plates. Let A be the area of the capacitor plates. A be the area of the plates. Okay, and there is a constant potential source connected across the capacitor plates, and value is given as 500 volt. We will put these values at last. First, you see, as given in the question, the capacitor is lowered into water in horizontal position like this. These are water. Let us take my loilo. There is the X thickness of the space between the capacitor plates is covered with the water, is filled up with the water. Okay, is filled up with the water. This is given as the water. Then at constant potential, our potential energy we know is half CV square, where C is the capacitance of the capacitor. Now, what we need to find out? We need to find out the pressure increment in the gap. Pressure increment in the gap. Okay, pressure increment we need to find out. We need to find out. For pressure, we need to find out the force on the dielectric medium. Okay, now here dielectric medium is the water, okay, which has the dielectric constant K. Let us suppose K force. Now how can we find out the force? Force is, we know that is minus du by dx. Okay, by using this equation we can find out the force if we know the potential energy of the capacitor, parallel plate capacitor. Okay, now for U we need to find out the C equivalent. We need to find out the C equivalent, because we need to put the C equivalent here, because we have two particular capacitance here. For this portion we will have one capacitance, this portion will have the other capacitance. So we need to find out the equivalent capacitance of this cap, and as we know, the equivalent capacitance we can find out by using the formula epsilon naught A by D minus X plus X by K. I will tell you how this formula comes. Moi kom je keneke tumalokor a formula to ahise. How did this formula came? You see, there is a constant potential source. Okay, this is K. So electric field here in this, let me take this as first gap. Okay, first gap. In the first gap, so what will be the electric field in air is E0. If it is E0, then electric field in the space where dielectric medium is there, so dielectric medium to ase tat kiman hobo electric field E0 by K, right? E0 by K. Jodi E0 by K hoy, total electric field yat kiman ase in the thickness. If it is thickness X, then this will be the thickness D minus X, right? This will be D minus X. So x thickness or electric field ase, this is electric field for x thickness, and E naught is the electric field for d minus x thickness. Okay, because the gap between the two parallel plate of the capacitor is d. So now what will the potential difference between the two capacitor plates? Here in x thickness, the potential difference is, we know that potential difference is E into d, we can write, so it is E naught by k into x, and here the potential difference, this is the V at x and this is V d minus x. Okay, so it is E0 into d minus x, is it? So total potential difference across the capacitor plates kiman hobo? It is Vx plus Vd minus x. Okay, ekhini potential difference moi koi asu Vx, I am telling it Vx, and for this much it is Vd minus x, and if we add these two potentials, I will get the potential difference across the capacitor plates, and that is come out to be E naught x by k plus E naught d minus x. Okay, so now what is the capacitance? We know that Q is equal to Cv, so C is equal to what? Q by V, is it? Q by V. Now if we put these values here, for V I can put E naught by k plus E naught d minus x, and for Q we can put sigma into A, right? Sigma is the charge density, sigma is the charge density. So for E naught, we know E naught value is sigma by epsilon naught. Okay, so we can put sigma A by sigma by epsilon naught k plus sigma by epsilon naught d minus x. So all the sigma will got cancelled here. Okay, so we will be left with epsilon naught. If we take it up in the numerator, epsilon naught a, it will be d minus x by epsilon naught plus, so no epsilon naught, d minus x plus 1 by k. Okay, 1 by k. So here we have left one x, so there will be one x, right? This one was E naught x by k, and this one is 1 by x, so here will be one x by k. So what we will get, the capacitance C is equal to epsilon naught a by d minus x plus x by k. So this is the process how the equivalent capacitance of this parallel capacitor with x thickness filled with dielectric medium called water is filled. Okay, so this is the formula for C equivalent. Now we have got the C equivalent as epsilon naught a by d minus x plus x by k, where k is the dielectric constant of the medium. Okay, now what was our U? It was half Cv square. Okay, now if we put half, the value of C is epsilon naught a by d minus x plus x by k v square. So this will be our potential energy here. Okay, so this will be our potential energy here. Now for force, what we will do, we will just differentiate this, because force is equal to minus du by dx. Okay, minus du by dx. Now if we need to differentiate it, d dx of this u, put the value of u here, to half epsilon naught a v square by d minus x plus x by k. Okay, so what we will get, half is constant, epsilon naught constant, a constant, v square constant. Is it v square constant? And what we left with is d by dx, and d minus, not d minus, it is, I think it is 1 by d minus x plus x by k. Okay, so what we can do, make it easier, half epsilon naught a v square d dx of, okay, d dx of k, k d minus x plus x. So make it, if we can bring the k here, because k is also a constant, so we are left with 1 by, if you do this kd, so this is kd, this we can do kd minus kx plus x here. Okay, so this equal to half epsilon naught a v square k d dx of 1 by x into 1 minus k plus kd. Okay, now what we can do, আমি কৰিব পাৰো epsilon a v square k d dx of x into 1 minus k plus kd. So etu koile ami ki pam, what we will get, etu koile ami pam half epsilon naught a v square k minus 1 by x into 1 minus k plus kd whole square, and here 1 minus k. Is it 1 minus k? So ultimately আমি কি পাম, half epsilon naught a v square k k minus 1 by x into 1 minus k plus kd whole square. Okay, now what will be the pressure value? যে আমার pressure value to কি, এটো আমার কি আহিলে, এটো আহিলে আমার, this is our, actually this is our force, F is equal to minus du by dx. Now what is pressure? Pressure is equal to F by A. So what is F? It will come out to be epsilon naught v square k by 2 k minus 1 by x into 1 minus k plus kd whole square, right? Now what the question is asking is the pressure when water is filled up the whole space. Okay, whole space in between the capacitor plates. Okay, so for this we just need to put the value of x equal to d. Is it? So then we can have the value of the pressure as epsilon naught v square k by 2 K minus 1 by D. In the place of X, we need to put the D into 1 minus K plus KD square. So this will come out to be what? Epsilon naught V square K by 2 K minus 1, you see, D minus dk plus dk. So dk minus dk plus dk will got cancelled. You will be left with only D square, right? So this is the pressure expression of pressure increment asked in the question. Okay, so if you put the values, K is equal to, you can find out the magnitude of this pressure by putting the value of this pressure by K is equal to 81 within then the value of D is given, okay, in the question, and also V is also given, it is 500 volt, I think. Now put these values, you will get the numerical value for the pressure. Okay, so this type of questions is basically important for JEE Mains and Advanced. So thank you.